Thank you for your interest in LinearBench Explore, Gistic Research's web-based application for viewing and analyzing LRS-referenced roadway asset data. This is the second in a series of videos describing some of the features of Explore. This video will focus on the application's temporal capabilities. Explore's interface and basic use is covered in detail in the first video, titled User Interface. We encourage you to watch it as well. A discussion of Explore's temporal capabilities must start with Gistic's innovative Timespace Diagram. This analytical tool displays a road segment and up to two assets, not only in a spatial context, or where they are located along the road segment, but temporally as well, that is, when these assets were established and retired. To access the Timespace Diagram, click on the second tab that appears along the top of the large center panel. For this demo, I'll select State Route 89 and enter mile measures 273 to 277. A narrower date range can be entered, but for purposes of this demo, I'll just accept the defaults. Click Go to view the stick map for this segment. Like the straight line diagram, the resulting graph includes symbolized roadway features, route measures displayed at bottom, and the road segment highlighted on the map. But in addition, the Timespace diagram has a time scale that appears along the left vertical axis. Now to add data to be analyzed. I'll first add speed limit data. Speed limit data is a linear period event, represented by a bar. It has a linear dimension, extending for a length of roadway, and a temporal dimension, its validity time. Its legend appears below, identifying the speed limit range associated with each color, as well as the total number of records displayed in parentheses. Based on the resulting display, we can see that speed limit data is not available prior to 2005 for this road segment. Next, I'll add crash data to our view. Crash data is a point instant event, represented by a point because it occurs at a specific location at a specific time. The default crash attribute is severity. As a result of this search, we are viewing the crash severity of the 77 accidents in the dataset, along with its legend. As an aside, we are proud to say that some of the key temporal LRS concepts adopted in the latest Linear Referencing System standard, ISO 19148, were developed by Gistic founder and CTO Bo Guo in his doctoral research and professional practice. To get a better sense of the power of the Timespace diagram, I'm going to switch over to the Straight Line Diagram tab and conduct a search of projects on I-15 from milepost 250 to 325. The resulting display indicates that along this stretch of interstate, there are 49 projects. But as you can see by the tooltips that display as I click along the diagram, they all overlap. If I conduct the same search on the Timespace diagram, I am able to get much more information. I can now visually distinguish the individual projects and easily access their details. You can change the symbology of a layer if additional attributes are available. To see if there are, click on the drop-down arrow of the first button to the right of the layer name. We are now viewing the value of each project, but we can change that by selecting, for example, Project Expense. To get a more granular view of projects in the spatio-temporal domain, you can use the set of buttons located at the top left of the diagram panel to change the view's time frame. Clicking the up and down arrows serves to shift the time period, while the plus and minus signs can be used to zoom in and out. Zoom in enough, and you can see the timescale change from years to calendar quarters, even months. We have just demonstrated the use of the Timespace diagram to explore the temporality of LRS spatial data. One other important aspect of LinearBench Explore's temporal functionality is the ability to display the history of assets and route networks, how they existed over time. This can be achieved by setting the as-of date or the date of observation. To do this, Click on the first feature button to open the LRS and LRM configuration dialog box. In this example, I'll change the linear referencing method from route measure to route reference, but will initially leave the date of observation to the default current date. On the Straight Line Diagram tab, I'll search for a segment of 99th Avenue between McDowell and Thomas Roads. Then I'll add the structures layer. Now I'll go back to the LRM configuration dialog box and change the date of observation to today's date in 2010. When I return to the Straight Line Diagram panel, you can see that on that date there were only 7 structures installed. Changing the date of observation has the ability to identify not only changes in the events displayed along a road segment, but changes to the route network as well. For example, a historical search on a particular road segment may result in fewer routes available to explore, which may reflect that they were not yet built or not yet incorporated into your network. That is the end of our demo. If you would like more information about LinearBench Explore or any of the other LinearBench Suite products, including a user login and password to access LinearBench's live demo site, please send us a message from the contact page on our website or give us a call. Thank you for watching.